The crisp February air bit at the faces of American tankers huddled beside the massive German Elephant tank destroyer on that muddy road south of Cisterna, Italy. February 24th, 1944. The 70-ton machine sat motionless, its engine long dead, abandoned by the crew that had fled. Soldiers from the 1st Armored Division circled the beast carefully, their boots sinking into the soft earth, examining this German colossus they'd finally captured intact. The armor told a story of violence. Countless American tank rounds had hammered against the thick 200mm frontal plate, leaving deep gouges and scorch marks where projectiles had struck and ricocheted away uselessly. But as these veterans moved closer, studying every inch of the metal monster, something struck them as deeply wrong, something missing. These men had fought German armor across North Africa, through Sicily, and now into the Italian mountains. They knew the German arsenal intimately. Every panzer, every assault gun, every tank destroyer that came out of German factories bristled with machine guns, defensive weapons for close fighting. But this elephant, this seemingly unstoppable machine, had almost nothing. One ball-mounted machine gun in the hull front, fixed to point ahead. That was it. Nothing protecting the sides, nothing covering the rear, nothing mounted on top. The realization spread through the group like cold water. Here sat one of the most heavily armored, most powerfully armed tank destroyers the Germans had ever built. Yet it was nearly defenseless against a single man with a rifle approaching from the flank. The implications hit them hard. This catastrophic design flaw suggested something the intelligence officers had been whispering about based on reports from the Eastern Front. The Ferdinand, later renamed the Elephant, was a monument to both German engineering triumph and a spectacular failure in practical thinking. Its very existence would soon force American military planners to completely rethink how they approached armored vehicle design. But how had such a glaring mistake ever made it past German engineers? The answer lay years earlier, in the ambitions of one man and the desperation of German military planners. Back in 1942, the German military launched a competition. They needed a new heavy tank, something that could dominate the battlefields of Europe and crush the endless Soviet armor rolling westward. Two companies threw their designs into the ring. Henschel and Sons offered a conventional approach, a turret mounted sensibly near the center of the hull. Then Ferdinand Porsche stepped forward with something radical. An electric drive system, engines positioned in the middle of the hull. Porsche, the personal friend of Adolf Hitler and an automotive genius, felt such confidence in his vision that he did something extraordinary. Before the competition even finished, before judges had even fully evaluated the designs, Porsche ordered 100 chassis built at the Nibelungenwerk factory in St. Valentin, Austria. His certainty proved spectacularly wrong. When the vehicles went through evaluation trials at Birka in April 1942, Porsche's design struggled in the mud. The novel petrol-electric transmission developed chronic mechanical problems. The Henschel design ran circles around it in reliability tests. Henschel won the contract. Their winning design became the legendary Tiger Y tank. Porsche's 100 chassis sat there, a massive investment with no purpose, no future, no value. German high command faced a choice: scrap them and take the loss, or find some use for them. They chose the latter. Engineers stripped away Porsche's vision and rebuilt the chassis into something new. They moved the engines forward and mounted a massive fixed casemate at the rear, armored and brutal, housing the main gun. They called it the Panzerjäger Tiger P, officially the SDKF 184, though everyone knew it by the name of its original designer, the Ferdinand. Between March and May 1943, 91 vehicles rolled off the assembly line. The specifications were staggering: 65 tons of steel and complexity. One of the heaviest armored fighting vehicles anywhere on the globe in 1943. The frontal armor reached an extraordinary 200mm thick, achieved by bolting an additional 100mm steel plate onto the original 100mm hull front. That made the Ferdinand's nose twice as thick as the famous Tiger I. No anti-tank gun from any Allied or Soviet arsenal of that period could pierce that armor when attacking from the front. The main gun was the 88mm Panzerjäger Cannon 43/2 fitted with an L-71 barrel, one of the most devastating anti-tank weapons ever bolted onto a tracked chassis. It could punch through 190 millimeters of steel at 1,000 meters. Soviet T-34 tanks fell to this gun from distances so vast the enemy vehicles were barely visible. Soviet tankers would later describe the terror of watching their comrades' tanks explode from shots that seemed to come from nowhere, fired from a machine so distant it appeared as only a tiny shape on the horizon. Inside the armored casemate, 4 crew members operated the massive gun. The commander called the shots. The gunner worked the controls and sent rounds downrange. 2 loaders muscled the enormous 88mm ammunition into the breech, but the driver and radio operator sat isolated up front in their own compartment, completely separated from the fighting crew behind them. Radio was their only way to communicate with the gun crew, a strange arrangement that would cause serious problems when battle came. Yet the Ferdinand carried serious flaws beyond its defensive weaknesses. The 2 Maybach engines, originally designed for much lighter vehicles, struggled against the 65-ton mass. Maximum speed on a road was only 30 kilometers per hour. Cross-country movement became a crawl at just 10 kilometers per hour. The complex petrol-electric transmission was innovative but temperamental, prone to overheating inside the confined engine compartment where heat had nowhere to escape. The suspension lacked return rollers, a choice made to save money that devastated track life. The tracks themselves, already stressed by enormous weight, wore down rapidly. Finding spare parts became increasingly impossible. The vehicle could travel only 90 kilometers before needing refueling. When a Ferdinand broke down or took damage, recovery became a nightmare. A single recovery vehicle couldn't budget. Multiple burger pans had to work together. Sometimes 4 recovery vehicles combined just to move one disabled machine. All 91 Ferdinands went to 2 heavy tank destroyer battalions. Schwere Panzerjäger Abteilung 653 received 45 vehicles. Schwere Panzerjäger Abteilung 654 received 44 vehicles. Together they formed Heavy Panzerjäger Regiment 656, commanded by Oberst Rudolf Gill. Their first real test came in July 1943 at the Battle of Kursk. Operation Citadel was Hitler's grand strategy to crush the massive Soviet salient bulging around Kursk. A double envelopment, a pincer movement that would squeeze Soviet forces between 2 German spearheads. Hitler had delayed the operation repeatedly, insisting on waiting for new wonder weapons to arrive. The Panther tank, the Ferdinand. He believed these machines would overcome the endless tide of Soviet numbers and deliver the decisive victory that had slipped away. 89 Ferdinands deployed for the Northern Pincer under Field Marshal Walter Model's 9th Army. Before combat even started, mechanical failures forced 6 vehicles into the repair shops. A troubling omen. The remaining 83 Ferdinands rolled forward ready for war. July 5, 1943, approximately 05:30 hours. Operation Citadel opened with a massive artillery barrage. German guns thundered across the landscape. Then the Ferdinands advanced, spearheading the assault, their mission clear. Destroy Soviet anti-tank guns and tanks at long range, smash the Soviet defenses, and allow German infantry and lighter armor to surge through. In those early hours, everything worked exactly as the designers had imagined. The powerful guns obliterated Soviet tanks before T-34s could close to effective range. The armor shrugged off anti-tank fire that would have torn conventional German tanks to pieces. Soviet soldiers watched in horror as their shells bounced harmlessly off the 200mm steel faces. Some Soviet tank crews, faced with this invincible force, simply abandoned their positions and ran. But the Soviets had prepared defenses far more extensive than German intelligence had ever imagined. The Central Front had laid over 400,000 anti-tank mines across multiple defensive belts. The Ferdinand's crushing weight made them catastrophically vulnerable to mines. When a mine detonated beneath a track, the impact could snap the suspension, bend the track beyond repair, or destroy the road wheels. The weight made field repairs nearly impossible. Of the 45 Ferdinands from Schwere Panzerjäger Abteilung 653 that went into combat on the first day, only 12 remained mobile by 1700 hours. The rest sat immobilized by mine damage. Most would eventually be repaired and dragged back to service, but pulling such massive machines off an active battlefield under fire became a nightmare. Soviet demolition teams crept out after dark with explosive charges, destroying abandoned Ferdinands before German crews could recover them. But something far worse soon became apparent. Soviet infantry discovered the Ferdinand's fatal vulnerability within days. The main gun had such limited traverse that it couldn't depress enough to shoot at targets close to the vehicle. No machine guns meant no close defense. When Soviet infantrymen closed the distance, Ferdinand crews had almost no options. Soviet tactics adapted rapidly. Special anti-tank teams would let the Ferdinands roll past their positions in trenches and foxholes. Soviet soldiers had trained for this, drilling exercises where tanks drove directly over occupied trenches. Once the Ferdinands pushed past the first defensive line, infantrymen emerged from their hiding places with PTRD-41 anti-tank rifles, demolition charges, and Molotov cocktails. The PTRD rifle couldn't pierce the thick armor, but it could damage engine decks, tracks, and vision blocks. A well-placed shot to the engine grills could start fires or rupture cooling systems. Shots to the tracks could immobilize the machine. Once a Ferdinand stopped moving, Soviet infantry swarmed it. Molotov cocktails splashed burning fuel across engine decks. Grenades tumbled down into ventilation grills, filling the interior with smoke and shrapnel. Ferdinand crews were trapped inside their armored tombs. They couldn't see infantrymen crouching meters away due to extremely limited vision ports. They couldn't shoot back because there were no machine guns. They couldn't drive away if tracks were damaged. Abandonment became their only option, a desperate scramble to escape the vehicle and reach friendly lines on foot. A journey that often ended in death. Some desperate crews attempted improvised defenses that bordered on suicidal. A few tried firing their MG-42 machine guns down the barrel of the main gun, rotating the massive 88mm gun to aim at attackers pressing close. It was absurd, dangerous, and almost never worked. Others threw open hatches to fire pistols and submachine guns, exposing themselves to enemy fire. These frantic measures rarely saved a vehicle. The Battle of Kursk became a catastrophe for the Ferdinand. While they achieved stunning kill ratios when engaging Soviet armor at long range, mines and infantry tore them apart. German records claimed Schwere Panzerjäger Abteilung 653 destroyed 320 enemy tanks, while losing 13 Ferdinands in combat. The claims, submitted by both battalions, totaled over 500 Soviet tanks destroyed. Yet beneath these striking numbers lay a far different truth. The Ferdinand's real losses stemmed not from enemy armor, but from something far more mundane. Mines tearing through tracks, engines seizing, and Soviet infantry closing in with grenades and determination. These powerful machines had been designed for something specific. Holding ground at distance, punishing enemy armor from prepared positions. Instead, they were being thrown into breakthrough attacks across Soviet defensive belts saturated with mines. The vehicles that should have stayed back were moving forward directly into the worst possible conditions. By July 12th, when Hitler called off Operation Citadel after the Sicily landings, only around 50 Ferdinands remained combat-ready from the 89 that had rolled into battle. The Kursk campaign had taught German commanders a harsh lesson. The Ferdinand had fundamental flaws that could no longer be ignored. That autumn, surviving Ferdinands returned to Germany for extensive rebuilding. The modifications took months at the Nibelungenwerke facility. Engineers mounted a ball and socket MG-34 machine gun in the hull front, giving the radio operator at least minimal protection against infantry attack. A new commander's cupola replaced the old one, featuring 7 vision blocks identical to those on the Sturmgeschütz 3 assault gun, dramatically expanding the commander's view of the surrounding battlefield. Zimmerit paste, that distinctive anti-magnetic coating, covered the hull and superstructure. The engine grille received redesigned protection as well. All these improvements added weight, 5 tons more, bringing the total to 70 tons. The engines and transmission received no upgrades whatsoever. The Ferdinand, already underpowered for its mass, became even more sluggish and strained. On May 1, 1944, Hitler personally decreed a name change. The Ferdinand became the Elephant, a new designation for a reformed machine that still carried the same fundamental limitations. By February 1944, 11 of these rebuilt Elephants headed to Italy. The first company of heavy tank destroyer Detachment 653, under the command of Oberleutnant Helmut Ulbricht, deployed to meet the Allied landings at Anzio. American and British forces had come ashore south of Rome, seeking to outflank Germany's defensive lines. Italian mountains proved even more treacherous than Russian steppes. Narrow roads twisted upward in hairpin turns, cut into rocky slopes, never designed for 70-ton vehicles. Bridges that had served civilian traffic for generations collapsed under such enormous weight. The Elephants had to splash through rivers, scramble up rocky terrain, navigate landscapes that challenged even much lighter tanks. Breakdowns came constantly. Engines overheated on steep climbs. Transmissions cracked under the brutal strain. Tracks shredded against sharp stone, worn down with no replacements available anywhere in Italy. When an Elephant broke down on a cramped mountain road, the entire route was blocked until the machine could be recovered or wrestled aside by other vehicles. American tankers got their first close encounter with an Elephant when Vehicle 102 from the Second Company suffered engine fire near Cisterna in late May 1944. The crew bailed out and abandoned the machine. American engineers descended on it, examined every millimeter, and confirmed what intelligence from the Eastern Front had been suggesting. Extraordinary armor, extraordinary firepower, but devastating vulnerabilities. The Elephant's vision capability was severely limited, particularly toward the sides and rear. That single-hull machine gun covered only a narrow forward arc. Most critically, the massive weight combined with inadequate engine power made mechanical failure almost inevitable. American intelligence drew a simple conclusion: this vehicle need not be feared during offensive operations. It would likely break down before reaching combat. American tactical doctrine was straightforward: avoid frontal engagements where the Elephant's armor and gun dominated. Instead, maneuver around the flanks or rear, let the machine destroy itself mechanically, or bring in artillery and airstrikes. Against the Elephant's thinner side and rear armor, even 75mm guns could penetrate. Of the 11 Elephants dispatched to Italy, only 3 made it out during the evacuation in August 1944. The rest were lost throughout spring and summer. Ferdinand 114 went down on March 1st. Ferdinand 131 on March 2nd. Ferdinand 113 vanished on May 25th. More fell during June fighting around Cisterna. Most were lost to mechanical failure, not enemy action. Vehicle 102, originally Ferdinand 633 from Kursk, was eventually captured intact and shipped to Aberdeen Proving Ground in Maryland for comprehensive American testing. The evaluations confirmed what engineers suspected. The Elephant was formidable within its narrow design parameters, but utterly impractical under real battlefield conditions. Meanwhile, on the Eastern Front, Elephants continued fighting through 1944, mostly in defensive operations across Ukraine. 2 companies totaling 28 Elephants reinforced Army Group South near Tarnopol. When properly positioned in ambush with infantry support, they were effective. But there were never enough of them to shift the strategic balance. Combat losses and mechanical attrition steadily whittled their numbers. A handful participated in defensive operations during the Soviet Vistula-Oder offensive in January 1945 as Soviet forces pushed deep into Poland. The last surviving Elephants fought in the final defensive battles south of Berlin in April 1945. Only 2 remained intact when the war ended. One Ferdinand, captured by Soviet forces at Kursk in July 1943, sits today in the Kubinka Tank Museum outside Moscow. The Elephant captured by Americans in Italy now resides at Fort Gregg Adams in Virginia. The fundamental question persists: how could German engineers design a 65-ton tank destroyer without adequate means to defend itself against infantry? The answer rested in the vehicle's improvised origins and the assumptions embedded in German doctrine. The Ferdinand was never supposed to operate alone. German combined arms theory called for tank destroyers to work alongside infantry. Infantry would shield the destroyer from enemy foot soldiers, while the destroyer engaged enemy tanks at long range. In theory, perfectly logical. In practice, Infantry could not always keep up with armored vehicles crossing rough ground or through fortified positions. Enemy fire might pin infantry down while tank destroyers pushed forward. Darkness or poor visibility could separate the two forces. Any of these situations left the Ferdinand defenseless. All of them happened regularly at Kursk. German designers had grown overconfident in their armor philosophy. They pursued maximum armor and maximum firepower while assuming correct tactics would overcome other shortcomings. The Ferdinand's designers believed thick armor would stop anti-tank rounds and the long-range gun would maintain safe distance from enemy armor. They failed to adequately consider close-range infantry threats, despite years of combat, proving that isolated or immobilized tanks were extremely vulnerable. The decision to eliminate adequate machine guns was deliberate, not an oversight. It reflected specific assumptions about how the vehicle would be employed, assumptions that collapsed under the pressures of actual war. The Ferdinand was optimized for one narrow scenario: long-range anti-tank combat from prepared positions with guaranteed infantry support. In exactly that circumstance, the machine was devastatingly effective. War rarely provides such ideal conditions. American tank destroyer designers absorbed different lessons. Vehicles like the M10 and M36 sacrificed armor to gain speed, reliability, mechanical simplicity, and multiple machine guns for self-defense. They prioritized mobility and practical functionality over maximum protection. American doctrine accepted that destroyers would depend on concealment and maneuver rather than thick armor. The contrast was striking. Germans engineered the ultimate defensive tank destroyer and discovered that ultimate defensive capability meant nothing if the vehicle could not survive approaching its defensive position. Americans built less impressive but more practical machines that could actually accomplish their missions under genuine battlefield conditions. The Ferdinand Elephant demonstrates the danger of extreme specialization in weapons design. When circumstances matched the narrow design parameters, it was nearly unstoppable. The moment circumstances shifted, catastrophic weaknesses emerged. Minefields immobilized it, mechanical problems sidelined it, infantry attacks destroyed it. The machine consumed precious resources while delivering limited overall combat value. Military historians today study the Elephant as a cautionary tale about practical design versus theoretical performance. The vehicle appears in armor development courses as an example of how impressive specifications can disguise critical operational deficiencies. It proves that weapons must be designed for harsh battlefield realities where plans unravel, not for ideal conditions that rarely exist. The two surviving examples stand as monuments to both German engineering ambition and the limits of over-specialized design. Visitors marvel at the massive gun and incredibly thick armor. Then they notice that single small machine gun covering only the forward arc and understanding arrives instantly. A seemingly invincible machine rendered helpless by the simplest threat: a soldier on foot with a grenade. For Soviet infantrymen stalking Ferdinands across Kursk's killing fields in summer 1943, that lack of defensive armament represented critical vulnerability. They exploited it ruthlessly, developing specific tactics to defeat these monsters, knowing that if they could close the distance, they could destroy 65 tons of steel fortress with weapons as primitive as a bottle of gasoline and burning cloth. For American tankers facing elephants in Italian mountains in spring 1944, the knowledge that the vehicle had extremely limited defensive capability and chronic mechanical problems took the fear factor away considerably. They learned to stay outside the elephant's killing zone at the front, and instead maneuvered to attack from positions where American guns could penetrate, or simply waited for the inevitable mechanical collapse. The Elephant ultimately proved that victory in modern warfare emerges not from building the single most powerful weapon, but from building practical weapons that soldiers can actually employ under genuine combat conditions. The tank destroyer that could barely defend itself against infantry became a textbook example of flawed design philosophy, a lesson that influenced armored vehicle development for decades. Ferdinand Porsche's repurposed chassis became one of World War II's most controversial weapons. It achieved remarkable kill ratios when employed exactly as designed. It inspired dread in enemy tankers who faced its massive gun and impenetrable frontal armor. Yet it also consumed enormous resources, suffered catastrophic losses to simple threats, and ultimately contributed little to Germany's strategic position. The Elephant stands as proof that in warfare, practical functionality matters far more than impressive specifications, and that the most advanced weapon is not always the most effective weapon.